Okay, Trig students, this is take 2 of this video. I spent 27 minutes recording a previous one and it didn't take my audio, so I don't know what happened, but hopefully this one's good. Okay, this is section 2.7. Now, since this is still technically a review of stuff that we did in Algebra 2, I'm not gonna go into going through the PowerPoints and teaching it like it's brand new, because it's not. So I'm just into WebAssign here using my Smart Ink, and we're gonna go over some of these questions, okay? Be looking on Google Classroom while we're out of school here doing things virtually for any updates, that kind of thing. And make sure you're looking carefully at due dates in WebAssign. Okay, so we're talking about functions and their inverses. First of all, let me just start by saying a function has to be one-to-one in order for it to have an inverse, okay? If you know the graph of a function, you can tell it's one-to-one if it passes both the vertical and horizontal line test. That'll tell you if a function's one-to-one, but verbally, it's for every x, there is only one y, and for every y, there is only one x. Okay, so if, like, just as a side note here, if I have my function f that takes the number 1 and maps it to the number 3, okay, actually so if this is my function f inverse is going to take the 3 and map it back. The inverse function is where we have f to the little, it looks like a little -1 power. Takes the 3 and maps it back to the 1. So my f of x function could have an ordered pair like 1, 3. My f inverse function would have the ordered pair 3, 1. Okay, or I could say this as f of 1 equals 3 and f inverse of 3 equals 1. Okay, so that's how inverse functions work. Every x gets mapped to a y, or every input to an output, or every domain to a range. And then the inverse function takes that same number in the range and maps it back to the number it came from in the domain. Okay. Okay, so for instance here, this first question, a function f has the following verbal description: multiply by 3, add 8, and then take the 5th power of the result. So it says write a verbal description for f inverse, okay? Now, when we're doing the inverse function, we're doing the opposite and it's in the reverse order, okay? So notice here that this first thing, it says multiply by 3, but over here, I've got divide by 3. Sorry, I had already put the answers in the boxes the first time I recorded this lesson. So again, multiply by 3 was the first step in the original function. Divide by 3 is the last step in the inverse function. So we do the opposite operation in reverse order, okay? The add 8 here in the original function gets turned into subtract 8, okay? And again, opposite order. In the original function, we have take the 5th power of the result, okay? In the inverse function, we have take the 5th root. And again, what turned in to each step is in reverse order, okay? Now, find algebraic formulas that express f and f inverse in terms of the input x. So for the original f function, again, we're taking our variable x, multiplying it by 3, adding 8, and then taking the 5th power of the result. So that means the whole thing has to be in parentheses to the 5th power, okay? Now, the inverse function, we're taking the 5th root, okay? So gonna have a bunch of stuff here under the 5th root, where I take our variable, subtract 8, then divide by 3. So this would be like x minus 8, all of that divided by 3. Okay, so original function, inverse function. Okay, again, opposite operations in the reverse order. Okay, hope that helps on explanation on that one. I'm using Smart Ink here in WebAssign, so I've got to erase each section before I move on. Assume that f is a one-to-one function. If f of 7 is 1, find f inverse of 1. Well, I kind of already covered that in the first one. Again, they reverse order, right? So f inverse of 1, if f has the ordered pair 7, 1, f inverse is going to have the ordered pair 1, 7. Okay, so this was for f, this was for f inverse. Again, you literally flip-flop. So the output would be 7. Same thing here. You put in 6, you get out -5. The inverse function, we started with the inverse, now we're at the regular function. Put in -5, you end with 6. Okay. The output of one becomes the input of the other, and the input of one becomes the output of the other. Okay. Now this one, number 3, if f of x equals 7 minus 6x, find f inverse of -41. Now, you could go through the steps of actually solving for the inverse function and then plugging in a -1, but really what they're asking us for, if you think about it, is if this -41 is the input of the inverse, then they're asking us what value of x would make that -41 the output of the original function. So what I'm really solving for here is 7 minus 6x equals -41. That's what I'm really solving for. I'm solving for the x. So what value of my input gives me the output of -41? Because that means in my inverse function, if my input is -41, it's going to give me that output. Okay, so what you're really doing there is solving for x. Okay, setting the function they give you equal to the input on your inverse. That should be the output of the original function. Okay, and number 4 here, same kind of deal. You're setting the x squared plus 8x equal to 9. Okay, now, ignore this a little bit. I mean, it's important, but what they're doing here is because we have a quadratic, okay, we could potentially get 2 answers for x when we solve. And so they're restricting which one it is. And why do you think they're doing that? Because a quadratic's graph is a parabola. And I can only use half of it if I need a one-to-one function. Because remember, parabola is not going to pass the horizontal line test. It'll pass the vertical line test, but not the horizontal. So we have to restrict the domain. We have to restrict the input values so that we only get essentially half of the function. Okay, that's what that is there for. So you're still setting x squared plus 8x equal to 9. But now when you go to solve it, okay, I shouldn't do this, but I'll just give you the next step. When you go to solve this, okay, keep in mind that your answer is going to have to fit in this domain, because again, this is a quadratic. So you're going to get 2 different answers for x. You want the answer that's greater than or equal to -4. Okay, so that's why the domain is important. Okay, all right, moving right along. Find the inverse function of f. So again, I'm going to step you through this, okay? First thing you need to do is substitute in your y for your f of x. So y equals 6x plus 2. Second step is you're going to switch x and y, okay? So now this turns this into x equals 6y plus 2. You literally switch your x and y variables. Then the next step is solve for y. Whoops. So if we solve for y, then we've got x minus 2 equals 6y, okay? So y equals x minus 2 divided by 6. This is the exact same thing as f inverse of x. F inverse of x is now this function. Okay? So that would be my answer. It'd be x minus 2 divided by 6. Okay? So again, when you're trying to find the inverse of a function, we know that's the equation of a line. We know it has to be 1-to-1. passes vertical and horizontal line test. So you substitute y for f of x, you flip-flop your x and y variables, solve for y. That is your inverse function. Okay. Same thing here, although you're going to have a cube root because you're going to have to solve when you start off with the cubed. So let me just kind of get this one started. So y equals 5 minus 3x cubed. Okay, flip-flop your x and y. So now I have x equals 5 minus 3 y cubed. Okay, so now subtract your 5, you're solving for the y. So x minus 5 equals negative 3 y cubed. Divide both sides by negative 3. Now, I'm going to take this a step farther here because I don't like having a negative on the bottom. So I'm actually going to like move the negative to the top. So this is going to give me y cubed equals 5 minus x over 3. Now, will WebAssign probably take a negative 3 on the bottom? I don't know. They may. I just don't really like the negatives on bottom. It's not a big deal. But now to solve for y, we would have to take the cubed root of both sides, right? So then my final answer would be cubed root of 5 minus x over 3 equals y, which is the same thing as my f inverse of x. So f inverse of x essentially equals that. Okay. Okay, hope that helps. Let me move on here. Where'd my eraser go? Same thing here. Okay, I did want to do number 8 because I want you to see the process when you have more than one y variable that you're going to be solving for. So again, first step is I'm plugging y in for f of x. So y equals x minus 8 over x plus 8. Switch your x and y variables. So x equals y minus 8 over y plus 8. Now, get the y plus 8 off the bottom. So now I've got to multiply this left-hand side by y plus 8 to get it off, right? You can think of it in terms of cross-multiplying or just multiplying both sides by y plus 8 and it cancels on the right, whatever. Now, this x has to be distributed. So this is xy plus 8x equals y minus 8. Now, once you get to this step, the goal is to get the two y's, the two terms that have y in them, I guess I should say, together on one side of the equal sign and all the other terms on the other side. So I am going to move my negative 8 over and I'm going to subtract my xy to move it over. So now my two terms with y's in them are on the right-hand side. The other two terms are on the left-hand side. Okay, so let me continue this. Next step then is going to be to factor out the y out of the two terms on the right. Okay, I factored the y out of both of those terms. If I factor y out in the first term, I'm left with 1 and then a negative x in the second. Now divide both sides by the 1 minus x to solve for y. So now y equals 8x plus 8 over 1 minus x. That is your inverse function. So this is f inverse of x. Okay, you have to isolate the terms that have y in them together on one side of the equal sign and then factor it out. Okay. Same thing with number 9, same exact process. Okay, let me erase so I can keep scrolling. Same thing there. Again, same thing there. Again, I want to point out that your domain is restricted here because if you're going to have to square both sides to get rid of the square root when you're trying to solve, you're going to be potentially, well, not potentially, you're going to be creating a quadratic. And we have to restrict the domain on the quadratic so that we only get 1/2 of it, so it remains 1-to-1. Okay, that's why that is. This part really has no impact on your calculations. Okay. Find the same thing with that one. Again, the domain is restricted for a reason, because when you go to solve for the inverse, you're going to end up with some squared term, because you're going to have to square both sides to get rid of the square root. And you have to restrict the domain to only take part of that graph to keep it 1-to-1. Okay. So again, it has no impact on your calculations. Now, the given function is not 1-to-1. Why is that? Well, mainly it's a function, okay, it passes the vertical line test all day long, but it is not a 1-to-1 function because it fails the horizontal line test. It crosses at 2 points, okay? So that's why it's not 1-to-1. That's why parabolas are not 1-to-1. Same thing. That's why we have to restrict domains to keep them to have part of it. So what we would need here, if we read the directions, restrict its domain so that the resulting function is 1-to-1. So essentially, if I could draw a dashed line down the middle of it, I need to restrict the domain to either the left side, which is going to be like -infinity up to 3, or to the right side, which is going to be 3 to infinity. I've got to have one side or the other. I can't have both, because once it hits that low point, that vertex, and comes back the other direction, it's going to fail the horizontal line test. Okay, so I pretty much just answered the question for you, but that's what we're doing. We're literally cutting it in half. Okay, so that we just have the piece of it that is 1-to-1. Okay, now these. Use the graph of f to sketch the graph of f inverse. Now, back to when we were talking at the very beginning. If an ordered pair in the f function is 1, 3, then that same ordered pair in the f inverse function is 3, 1. So literally the easiest way to draw these graphs is to look at all your ordered pairs. This ordered pair right here is the ordered pair 10, 9. Its counterpart, or counterpoint, I guess you could call it, in the inverse function is going to be 9, 10. So this right here, the point 9, 10 is its counterpoint. Okay, I just drew a little dashed purple line there so you know that point gets mapped to that point in the inverse. Okay, now, so my inverse function, sorry, is going to be my blue. Okay, blue dots for the inverse. Now, this point right here is the point, what, 1, 2? So the point 1, 2 is that point. Its counterpoint in the inverse function is going to be 2, 1. Okay, so this point would get mapped to that point. Now, let's keep going. This point here is the point, what, -9, -3? Okay, -9, -3. Its counterpoint in the inverse function is going to be -3, -9. So -3, -9 is its counterpoint. Okay. Now, next, this point right here is what, -10, -7. So its counterpoint in the inverse function is going to be -7, -10. Okay, that's the counterpoint. We literally flip-flop the x and the y. So if I draw a straight line now from each of these points, let's see if I can manage to do this without screwing up too badly. Okay, that is my inverse function graph. Okay, dude, I can't even stay on a straight line. You all get the idea. Okay, now Anytime a graph and its inverse are on the same graph, they will always reflect, always reflect about the line y equals x. Okay, they will always reflect about this line. So if I were able to fold the board, notice that this black line should have gone through, if I could draw correctly, should have gone through the point where they cross the red and blue lines. Okay, so if I were to fold the board on the black line, y equals x, okay, those two should mirror each other. Okay, they are symmetric about the line y equals x. That's your typical line with positive slope of 1 going through the origin, 45 degrees. Okay, so anytime you're graphing a function, the easiest thing to do is pick out points and then flip them for the inverse. Okay, and then it's just a matter of connect the dots. Okay, hope that helped on that one. You've got a couple like that, if I remember. Okay, same thing. Okay, for his services, a private investigator requires a $750 retainer fee plus $55 per hour. Let X represent the number of hours the investigator spends working on a case. Now, first of all, just in general, anytime I'm doing word problem type stuff with cost, I always think in my mind that total cost of anything equals fixed cost plus variable cost. Now, for instance, if you use sometimes services like a website or a call in to order concert tickets, a lot of them, there's some flat fee that they charge you to just call in or log in. Then there's the cost per ticket. Okay, so that's what I'm talking about. The fixed cost would be the fee that they charge you for using the service. The variable cost is how much the tickets cost a piece. Okay, if you rent an apartment, there's usually some kind of deposit that's required. Okay, that would be your fixed cost. Then your variable cost is the amount of the monthly rent. Okay, so that's your variable cost is the monthly rent. The fixed cost is the deposit. So that's what I'm talking about. So in this example, he has a $750 retainer that's just to use his services. That's not for him doing anything yet. And then the variable cost is the $55 per hour. The variable cost is always going to be where your variable is. Okay, so that essentially is our function. That's it right there. So 750 plus 55x, or 55x plus 750, doesn't matter. So then find f inverse. I think you guys can do that. You can solve that. Okay, I just kind of wanted to go over, that's anytime there's some kind of cost problem, that's always how I kind of break it up in my head. Fixed cost, variable cost. Here, this is a pretty popular one. So we have the basic equation that Fahrenheit temperature equals 9/5 of Celsius plus 32 degrees. Okay, that's a basic known formula, and we can actually derive that formula if we just have 2 points. So like the point 0 in Celsius is the point 32 in Fahrenheit. The point 100 in Celsius is the point 212 in Fahrenheit, the freezing point and boiling point of water. So that's how that formula was developed. Now, the inverse of that, what they are looking at is that C equals. Okay, so on this one, you do not want to flip your F and C's. When we're dealing with X's and Y's, we always like X to be the input, so we flip-flop the X and Y to solve. On these, you want to leave your F and C's. Okay, so all you're doing here for the inverse is just solve for C for the G inverse function. Okay, that's what you want to do, solve for C for the G inverse function. And then obviously solving for C means you have the Fahrenheit temperature, you're trying to convert it to Celsius. Okay, I actually had a thermometer in my old classroom at Wentworth that it was kind of broken and the knobs were busted, and so it always gave me the room temperature in Celsius. I had to use that formula to figure out what that was in Fahrenheit every day. Okay, Moving right along. I think we're pretty close to being done here. Car dealership advertises a 10% discount on all new cars. In addition, the manufacturer offers a whopping $150 rebate. That's pretty sad. Now, $1,500, maybe. $150, that's pathetic. On the purchase of a new car. So suppose part A here that only the 10% discount applies. So essentially we're taking the full price of the car minus 10% and then taking that times the sticker price. So in my mind, I don't even really think of it in terms of what I just wrote. I think of it as if it's 10% off, I'm paying 90% of the sticker price. Okay, when I go shopping and something is 20% off, I am looking at the tag and taking it times 0.8 in my mind. Okay, it just kind of avoids the step of subtracting. So part B, suppose that only $150 rebate applies. Well, that just means you're taking the sticker price and then just literally subtracting $150. That's it. So now the next one, find the formula for H, which is f of G. Now we're doing composition of functions, which we did in a previous section. So this is the same thing as f of G of X. So essentially what they're saying is we're taking the rebate off first, then we're applying the discount. Okay, that's essentially what this is saying. So this is f of x minus 150, which is, now we apply the f function, 0.9 times x minus 150. And you would have to distribute your 9, okay, to get your function. And again, what this is saying is, okay, if the car dealership combines them, a lot of times you can do this to figure out what's your better deal. If you've ever gone to like Bed Bath & Beyond, they're big on coupons. Do you just get the $10 off, or do you take the 20% off coupon that they mail to every Tom, Dick, and Harry in the world? Which one do you apply first? Which one gives you the better value? So in this case, on part C, they're saying if we apply the rebate first and then take 90%, what's going to be my final cost? Okay, so I will leave you to the rest of this. I think that about covers it. Let me scroll down and make sure we've covered all the main things. Yep, that's it. Okay, so keep looking in WebAssign for due dates and keep checking your Google Classroom. I will be posting the PowerPoints for every new section we cover, and I will be posting a lecture like this one. Okay, if you have any questions, email me and we can set up a time in Google Meet. Okay.